For some applications and sensors, you may want to include the total number of rising edges on a selected GPIO, and then include that total count in one or more of the advertising sets that are sent out by the IN100. In this video, we'll go over how to do that using the NanoBeacon Config tool. So let's get started. So for the GPIO edge count, the length is going to be 3 bytes. That's the length of the counter. So that gives you a total of over 16 million counts. To configure this, we have to first set up the GPIO to be in the input mode. So I'm going to be using the GPIO 4 on this evaluation kit on the dev kit. And I set it up in input, pull down, and then disabled the advertising trigger, the wake up. And once we do that, the next thing that we want to go ahead and do is set up the GPIO edge count. So make sure first that you have the GPIO set, and then choose enable the GPIO edge count, and then basically choose the GPIO of interest that you're using. So I'm going to be setting up GPIO 4 as we've seen before in the GPIO settings. And then I'm going to go to the advertising settings, and I'm going to be using just one advertising set. And for this one, the settings, I have just a name that I call GPIO space CNT for counter. And then in the manufacturer specific data, I added the edge count and big endian format to be easy to read, to make it easier to read from the raw data that's displayed in NRF Connect, as well as the GPIO status for all the GPIO pins. So I'm going to reset the board, and I also have for this case, I'm going to be using a signal generator, and I have an oscilloscope connected just to verify that the output is correct. For the signal generator, I'm using 100 Hertz with an amplitude of 3.3 volts and an offset of 3.3 volts. This is all DC. This is what you can see here in front of you on the signal generator. And then on the board, I have a pin from the pinout from the GPIO 4 connected to the signal generator, as well as the oscilloscope. And then I also have ground connected as well to both of them. And that's coming out from here. So now here I have the NRF Connect, and I'm filtering based on the Bluetooth address that's set here in the advertising parameters for advertising set number 1. Let's go ahead and run in RAM. Once we do that, now we see the advertising being sent out. However, if you look at the last byte, which is E5, again with E5, this indicates that GPIO 4, if I convert that into binary, the 4th pin is set to 0, so it's off. And in terms of the count is again 3 bytes. As you can see here, it's all zeros. Now let's go ahead and enable the output on the signal generator, and I have it at 100 Hertz, so the counter will be going up very quickly. It'll be counting the rising edges on the GPIO. So let's go ahead and enable the output, and as you can see here, the counter is going up rapidly. It's now up to 25F, 327, and that's all in hex, and it keeps going. We can adjust the frequency if we want. We can adjust the duty cycle. That won't affect the counter, but we can adjust the frequency to increase or decrease. This is basically a simulation, and it's not a real case, a real use case. However, in your case, when you have an application, you have the GPIO, maybe you want to count how many times it toggles on and off, and that will give you some information about in this use case and the specific application that you're developing for. So that's it for this video. This was a short video just to kind of simulate and let you know how to configure the GPIO edge count and include it in the advertising data. Thank you for watching. I'll see you in the next video.